start. Am I audible clearly?
Yeah, yes, ma'am. Yes, ma'am. Yeah, you are.
Okay.
Just wait for 2 minutes, ma'am. We will start now.
Rashmi ma'am, good afternoon.
Yeah, good afternoon. Good afternoon,
Yeah,
Dr.
welcome ma'am.
Vijay.
Welcome for today's session. Sorry for bit
Thank
delay
you.
for the link.
No,
Thank you. Thanks for joining.
no problem.
Yeah,
Yeah.
it's honor to have you today. Please.
Okay. So shall I start?
Yeah, wait ma'am. Let them will introduce, and once the participant will join, they will announce ma'am. Kindly
Okay.
stay in touch.
Okay.
Okay.
Viji ma'am?
Ma'am, yes, ma'am. Ma'am, shall we start, ma'am?
Yes, ma'am.
Yeah, yes, ma'am.
Good afternoon, Rasmi ma'am.
Yeah, good afternoon to everyone. Good afternoon.
I'm Vijayalakshmi ma'am,
Okay.
CSE HOD. Good afternoon, ma'am.
Good afternoon, everyone. Good
Okay.
afternoon.
Viji?
Yes, ma'am. Shall I start?
Yeah,
Yes,
yeah.
Yeah, very good afternoon to one and all present here. On behalf of Ramco Institute of Technology, Department of Computer Science and Engineering, I welcome you all for the Day 2 International Conference on Smart Technologies and Applications 2022 Invited Talk on AI and its applications in computer vision. I welcome our today's chief guest, Dr. Rashmi Gupta ma'am, Professor and HOD ECE at Incubation Center, Netaji Subhash University of Technology, New Delhi. I welcome you, ma'am. I also welcome our beloved principal, Dr. L. Ganesan sir, and vice principal, Dr. Rajakarnagaran sir, and our organizing secretary, Dr. K. Vijayalakshmi ma'am. And also I welcome all the participants for this session. I welcome once again. Let me introduce our today's chief guest, Dr. Rashmi Gupta ma'am. Dr. Rashmi Gupta ma'am is working as a professor at Netaji Subhash University of Technology, East Campus, New Delhi, India. She completed her PhD in Electronics and Communication Engineering, Delhi College of Engineering, University of Delhi. She completed her MTech in ME Electronics and Communication Engineering, Delhi College of Engineering, University of Delhi, and she did her BE Electronics and Communication Engineering, IETE Delhi. She has 19 years of teaching experience and 8 years of industry experience. Her area of specializations are image and video processing, digital signal, security, machine learning, computer vision, biometric recognition, and wireless communication. She has published more than 80 papers in SEA journals. She guided 150 UG projects, 70 PG projects, and she guided 7 PhD research scholars and awarded 1 PhD. She is a co-principal investigator for the project title Design and Development of Novel Instrument Retrieval Equipment for Removal of Separated Instrument During Endodontic Therapy with Maulana Azad Medical College, funded Department of Science and Technology. She has published 3 patents. She is a member of IETE, IEEE, IDES. She is a reviewer of for IEEE Transactions, IET Image Processing, IJI Journal, IJIT, IGI Global, and MJCS journals. I'm so glad to have such an eminent resource person in our session. I welcome you, ma'am. Now I hand over the session to you, ma'am.
Thank you so much for introducing me so nicely.
Thank
So
you.
before starting my session, I would like to congratulate all the members of organizing committee for conducting this wonderful international conference on smart technology and applications. Everyone know that this is the topic of today demand. So congratulations and thank you for inviting me to have expert lecture in this conference. Thank you. So I am now starting my lecture. So I'm sharing my screen. I think I need permission to share my screen.
No, ma'am, it is
Some
not.
yeah, the message is coming that you can't share your screen. Need permission.
Actually, there is no restrictions like that, ma'am. You can present your screen, ma'am.
Again, I will try
Oh,
entire screen. I think now it is okay. So my screen is visible.
yes, ma'am. Now it is visible, ma'am.
Okay, thank you so
Yes,
much. Yeah. So topic of today's session is artificial intelligence and its applications in computer vision. Fine. So how the presentation flow will be like first I will discuss about very brief about what is artificial intelligence and what are the various methodology to implement artificial intelligence like machine learning and deep learning. After that I will discuss computer vision like computer vision is also the subset of machine learning and deep learning. Indirectly you can see it is a part of artificial intelligence. And in last we will discuss applications of artificial intelligence in computer vision. So before discussing application of AI in computer vision, we need to know about AI, ML, DL, everything. So actually, what is AI? AI means artificial intelligence. Everyone knows that it is a part of automation, and automation is a hot topic nowadays. The conference topic is also smart technology and applications. So indirectly, you can see it is AI only. So, and it is receiving a stream buzz in recent years. And if anyone has a in-depth knowledge of AI, then it is a huge potential as a career opportunity. So, what exactly AI means? AI means we are enabling machine. Machine may be a computer to behave as a human. Means like human behave very intelligently. He can take decision at his own what to do next. He can recognize the object, nearby object, and either some if you are driving the car, so you can see that there is some obstacle, you will stop the car. So such kind of all intelligent decision is taken by human being itself. So all this technology we have to built in machine, and this machine is called this technology is called artificial intelligence, which make machine intelligent enough to behave like a human behavior. I think it must be clear to everyone. AI means which enables machine to behave like a human behavior. Human behavior means human is taking decisions smartly. It is capturing the images and it is observing the things and everything. And in last, human can take decision based on its intelligence. Means it is using its human brain. Now, what is then ML and DL? ML means machine learning and DL means deep learning. These both are the techniques which are used to make machine intelligent. Means to behave machine as human behavior, we have to implement some methods, some techniques. So machine either by using machine learning or deep learning technique, we can make our machine smart. So ML, machine learning, and deep learning is the subset of AI. I think it must be clear. To make our machine intelligent, we have to use some techniques. This may be either machine learning or deep learning technique. So what is difference between machine learning and deep learning? So in machine learning, what we do, we use some statistical methods to enable machine to behave like a human behavior. Means how will it do? It will use some methods which will make machine to learn with experience, and slowly and gradually it will improve with the experience. Means we will feed lots of data to the machine and we will make the machine to learn and improve with experience. Like everyone in childhood, when a baby take a birth, he or she does not know anything about the environment. Slowly and gradually, by learning, he or she understands how to walk, how to speak. We make the child learn. Similarly, same thing has to be done in the machine learning algorithms. We have to learn the machine by feeding lots of data, so that in the future when the some unknown data is given to the machine, it will able to recognize, because lots of data has already been given to the machine. So what is the machine learning? Machine learning means it uses some statistical method to make machine to learn and improve with experience. Fine. Now, what is deep learning? Deep learning is also used to make our machine smart, but it is using the technique of our human brain. Like human brain, there are a number of neurons. So, based on that technology, deep learning algorithms are inspired by structure and function of human brain. It means it is deep learning is made up of multi-layer neural network structure. So nowadays, deep learning is very very in topic, because it is giving very surprising results in the AI. So these are the two different methods to make our machine smart, either machine learning and deep learning. So we can use depending upon the application, either machine learning or deep learning technique to implement to make our machine autonomous or to behave as a human. Now, what is computer vision then? Computer vision, again, it is broadly subfield of AI. Actually, in AI, the data could be either test data, or it may be sequential data, or it may be audio, image, something like this. But if we particularly talk about computer vision, in computer vision we are feeding only it will be work on images only, images, videos, or audios. So that is why computer vision also the subfield of AI, ML, DL, you can say. Again, it is a field of AI which may use ML or DL techniques to make our machine smart. But in the computer vision, it is working on the images, mostly images, audios, or videos. But this is a subfield of AI only. So I think it is clear what is AI, ML, DL, and CV. Now, before proceeding further, either AI or computer vision, I told you that we have to use either machine learning or deep learning techniques to make our machine smart. So, what is the basic difference between machine learning and deep learning that I will discuss here? So, if you can see the suppose our motive means our computer motive or machine motive is to recognize either it is a input given to machine is a car or not. So if we are feeding this data to a machine which is having machine learning algorithm, and then how will it behave? What it will do? It will first that there are two main stages. Number of stages are there, but there are two main stages. Number one is feature extraction. Number two is the classification. In feature extraction, what the machine will do, it will recognize, like you don't see that we can see that this is a car. We are already trained. But machine, we have to train the machine. So how the machine will be trained that this is a car? We will machine will extract some useful features. Features may be like shape of the car, color of the car, texture of the car, or some dimensions of the car, something like this. It may be anything. It depends upon the engineer who is making this algorithm, what kind of features you want to extract. So in first step, we will do the feature extraction. Based on the features, then the machine will classify either this is a car or not. So this is how the machine will work. So जो part है, main part is of feature extraction part, because depending upon the how dominant, how useful features you are extracting, based on that we will get the accuracy here, either it is 90%, 99%, whatever it is. So at the time of developing algorithm, these two parts are very important. Fine. After that, deep learning. So what is difference between machine learning and deep learning? Like I told you, this is some statistical method, machine learning. Some statistical methods we are using. In the deep learning, we are mainly using structure of neurons. Fine. So what is the big advantage of deep learning here? Here we need not to use any feature extraction method. Here in the machine learning, it is very tedious task to extract some feature extraction algorithms. But here deep feature extraction and classification will be done by itself only. Only we have to create some model that is based on the neurons that we will discuss later on. So this is a basic difference between this. Here the feature extraction and classification will be done at its own. We don't need to have select any feature extraction methods. So this is a very big advantage of the deep learning. Fine. So this is the main difference between machine learning and deep learning. So if we discuss again now, in deep learning, it enables machines to take decisions with the help of artificial neural network. Like I told you, this is the structure of artificial neural network. So decision will be based, this decision, here is a decision we are taking, either this is a car. If it is a car, we can say its value is 1. If it is not a car, then its value is 0. So this is the two stage classifier, you can say. So here the decision is based on with the help of artificial neural network. And what is the big disadvantage of deep learning? To train the model, like we have to train this model. So we have to feed lots of input data, various kinds of images of car, that it will learn itself that this is a car. So huge amount of data is required to train the network, and then only the accuracy will be good that this is a car or not. So large amount of training data is required in machine learning algorithm. This is a big requirement here. So to train large amount of data, we need high-ended machines. Like general in computer, you are using CPU, but here we require GPU. This is a thing. So generally, we don't have GPU in the colleges. Few colleges have GPU. This is a big advantage. Otherwise, all the benefits are of deep learning. So machine learning learns the feature from the data it is provided. I told you that it will learn the feature automatically. That we will discuss later on, how it is learning the features automatically. Now the problem is solved in an end-to-end manner. In end-to-end manner means we are giving the input and it is giving the result. But here there are two stages mainly. We have to use the feature extraction, then classification. So this is end-to-end manner we are getting the output. Now, in deep learning, it is mainly used for unstructured data, and machine learning is used for structured data. What is the meaning of unstructured data? Like if we are talking about images, audio, videos, etc., or some social media posting, etc. So these are all are unstructured data. So it is working well on the unstructured data. While in machine learning, it is really difficult to get good results in case of unstructured data. In machine learning, you need some structured data, means in some format in Excel sheet or something like this, you need the data to train the system. So this is a basic difference where we will implement machine learning and where we will implement deep learning techniques. Now, machine learning versus by this diagram, what we want to show that how will you decide you want to use machine learning or deep learning? What is the performance of machine learning and deep learning? Performance means what is the accuracy? Like if you are recognizing the car, if you are feeding 100 car, 99 times if it is giving right result, then we can say it is 99% accuracy. So accuracy parameter is very important to check the robustness of any model. Fine. So like in XSS you have amount of data. As long as amount of data is increasing, here you can see the performance is shoot up in case of deep learning, means it is improving exponentially. While in machine learning, after some amount of data, the accuracy is constant. Means if your data set is small, then result of DL and ML both are same. But DL is computationally expensive because you need load, you need the GPU, etc. So for small set of data, if you have very small set of training data, then you will use machine learning algorithms. But if your data size is very large, then you can say accuracy will be increased in deep learning techniques. So for if you have large amount of data, then machine learning this accuracy is less, performance is less, while these deep learning performance will be very good. Fine. So this is the basic difference. So here you can see in machine learning training data less, downward arrow means less amount of training data is required, while in deep learning training amount of data is large, very large amount of training data is required, but reverse in the case of testing data. In machine learning, testing data is, but the accuracy in testing data is less. Test while you get very less time to get the testing, but in the deep learning, oh sorry, large amount of testing time is required in machine learning, while in deep learning you require less time of testing. Means when you are training, then the training time is large. In case of deep learning, it takes sometimes weeks or months to train the model, but when you test the result, it will give in fraction of seconds. But in case of machine learning, reverse is there. Training time is not very high, but testing time is very high. So this is initially in deep learning, training time is high. You need to train the model very accurately, but later on it will work very good. Testing time is less, accuracy is more. So all the benefits of deep learning. Now, so we cannot say that only deep learning techniques are using nowadays. Machine learning are also using when we have less amount of data, or in some applications, machine learning will also give good results. So we have to study both type of techniques, and depending upon the application, we will choose either ML or DL to implement AI to make our system intelligent. So I'm giving very brief overview about machine learning algorithms. Just I'm depicting some name. Like if you have studied that common machine learning algorithms, you must have listened, heard about this. That there are linear regression. Actually, which technique you have to use depend upon. Like some techniques are supervised, some techniques are unsupervised, and some are reinforcement learning. So one is supervised learning, unsupervised learning, and reinforcement learning. So like linear regression, logistic regression, decision trees, SVM, all these are the methods of supervised learning. Supervised learning means when data labels are given. You know what is the name, when you are training the data, you know the labeling of each type of data. But some others are unsupervised learning. Unsupervised learning, you don't know, the system does not know when you are feeding the input, you don't know the name of the input data labels, data are not labeled. So then it is called unsupervised learning, and these are the name of the unsupervised learning. K nearest neighborhood, K means clustering. So it will in the final stage it will classify based on the cluster, something like this. Other techniques are random forest, ADA boost, SG boost, and many more techniques are there in the machine learning algorithm. So you can, like for any of your application, you can try or study all these applications, and then you can see in what kind of application, what kind of results you will get. This is again machine learning algorithms. We have divided like supervised, unsupervised, reinforcement. In supervised learning, linear regression, logistic regression, SVM. In unsupervised learning, it is K-means and PCA, principal component analysis. And third one is reinforcement learning. So it is just an overview of all how the machine learning algorithms you can classify. Now, next is the deep learning. I will discuss more about deep learning because in computer vision, most of the time we use deep learning using convolution neural network. So I will discuss more about this. I have just given the overview of your machine learning algorithms. So now, what is deep learning using convolution neural network? I don't know either you have aware about this or not, but like it is a basic block diagram of deep learning technique. Hmm. So here, like this is a input images. We have to feed number of input images to train the data, and at the later stage, it will identify. Like if you have identified, you want to identify some facial structure, face which like it is a face of A person or B person, something like this. Suppose this is a kind of network. This is a very basic diagram which is used in all types of CNN, convolution neural network. So some image is given to the system. The number of images will be given to the system to train this model. Fine. So first layer will be the combination of convolution and pooling layer. And this combination may be one layer, two layer, three layer, four layer. Number of hidden layers are there for any CNN. I have shown here only one layer. Like if I like this is the one layer only, convolution and pooling layer. After this is a part of fully connected layer and this is the output layer. Now, how many layers we are using depending on, like at the first level we are setting the low level feature. Same type of layer we will use at the in the subsequent series of this, and we will get medium feature level. After that again we are using one more layer and we will get high level features. After that it will be given for classification to the fully connected layer, and it will recognize whose face of a person is this. So what the convolution neural network is doing, it is stating the feature itself. Earlier, I told you the difference between machine learning and deep learning, that CNN extract the features itself. We are not using any algorithm to detect the features. We are using just convolution neural network. What is CNN? I told you. I will tell you in the subsequent slides how it will work. But from this diagram, you can see at the first output of the layer, you will get this low level features. Low level features means some edges, dark spots, etc. After that, again, it will be feed to the second layer. It will give you the mid-level features. You can see eyes, ears, nose, something like this. After that, again, we are feeding to the third layer, same type of layer. You will get the high-level features. These island faces or facial structure you are getting. So this is the beauty of your deep neural network, that you are getting the features itself. So I will explain you how we are getting the features, but you need not to select any kind of feature extraction method. It will do at your own. So this is how it will work. Deep neural network, we are extracting the feature itself. After that, what we will do, like images are in the form of matrix. Output is like this. For classification, we will what we'll be doing, it will be converted to the fully connected layer. What is fully connected layer? Like this is the first row. It will be given in column. Second row again in column. Third row is again in column. So this is a column vector. So fully connected layer is column vector, which has converted this matrix into the column vector, and this vector is used for classification. Fine. After that, final stage is the some classifications like softmax layer. If you have heard this word, softmax layer, it is used for classification. Like it is a face of a person A, B, or C. So what we it use the probability of image to classify to which class it belongs. Like suppose it is a person A, B, or C. Probability of this node is 0.8. It's 0.1, zero point 0.1. So we will say, if we are feeding this input, if the probability of A is 0.8, so we will say yes, this is the person A. Means the probability of the image which is higher, we will say that this is the image of this particular person. So based on the probability, output will be classified to a particular image. So this is how your CNN will work in deep learning. Now, like in the first stage, we have some convolution. So in this slide, I will just give you the overview, like what is the meaning of convolution. In convolution, what you have to do, you have to select some features, filters. Like it will randomly select by itself CNN. It will assign some weights automatically. Suppose this is a filter, 3 by 3, 3 rows, 3 columns, and these are the values. These values are called weights in the CNN. And in the subsequent time, every time it is training, these weights will get updated every time. Like first time it will get, you will get some result. You are getting some result here. It is not, again it will be some loss function is more. Again the system will be trained and weights of the filter will be updated. So same thing will be happen. These weights will get updated by itself based on the value of the loss function. So how we apply this weight? What is the meaning of convolution? Like this is your input image which you are feeding to the network. When we are feeding the image to the network, it is not taking the phase. It will take some gray level values. So it will be taken as a matrix of a phase and which has some gray level values. Now, depending upon the weights of the filter, this filter will be convolved with this mask and you will get some new value. What is the meaning of this? Like this filter will be overlap on this. Okay? And all the corresponding values will be multiplied and all the values will be added after multiplication and divide by total number of pixels, and means you are getting average of this value, multiply by corresponding values and adding and then dividing by number of pixels. So you will get the new value like 0.77. How this new matrix will be taken out after convolving this filter with this matrix. Fine. After doing this, you are getting this central pixel new value. This value will be changed. Again, you will shift the filter, this same filter to the next one stride forward. Fine. So it will come here. Fine. It will come here, and again corresponding values will be multiplied, addition and divide by number of pixels, and you will get this new value 0.001. So this filter is convolving with the whole image, and we are getting the new value. So this is at the first stage. This is called low level features. You are like low level features. We are getting edges or dark spots, something like this. If you convert this into the form of the image, I can roughly say you this is this kind of image after convolving the filter with the image. Fine. So how this is working? Artificial neuron, you must have known the structure of artificial neuron. Same way convolution is working. With the input pixel value, you are multiplying the weight of the filter. Second input value multiplying by filter. What is the meaning of this? Like this value you are multiplying with this value multiplying with the weight of the filter. All these values are multiplying like this. After that, summing of all the values, then addition with some bias value. Bias value, what will it do? It will do the output near to the exact value of the output very quickly. So we add some bias value also. After that summation of these value, we pass it to the some activation function. What is the activation function? I will tell you like this. Suppose in CNN, most generally we use ReLU activation function. There are different ReLU activation function like 10H, leaky ReLU, bilinear ReLU, so many that is research is going on. But here we are just discussing the basic concept. So here we can see here we are using the ReLU activation function. What is ReLU activation function is doing? It is doing like if some values you can see very close to negative values, minus 0.11. Here it is like this is also minus 0.11. This value is minus 0.11 minus. So all the values which are negative values, but it will do ReLU activation function. Positive values will remain as it is, and negative values will remain 0. So when you pass this output value, low level features to the activation function, it will convert low level values to the 0 values. You can see. Fine, this value. Why we are doing this? By doing this, these were the unimportant pixels. If we process it again and again and update the values, it is complicating our system. It will take more time to train the system. So complexity is very important factor. We have to reduce the complexity of the system as much as possible. Fine. So unimportant values are converted to 0. So these weights will not be updated in the next layer. So this is the beauty of this ReLU activation function. So by using this, we are removing unimportant pixels. Fine. After that, you can see in this diagram, in convolution, this is a artificial neural network plus activation function is used in this part only. After that, we are using pooling. What is the meaning of pooling? I can tell you. Again, it is used to do the dimensionality reduction. What is the meaning of dimensionality reduction? Here we are reducing the size of the image. Like it will do like this. It will take, suppose our pooling filter size is 2 rows 2 column. 2 rows 2 column means like this. Fine. No, this is 3 rows. 2 rows 2 column. Fine. So we will convolve this 2 rows 2 column with this, and we will put the mathematical function maximum of all these values. What will it do? It will keep maximum values of among all these pixels. Here maximum value is 1. So here we will get 1 only. Again, we will move this filter to this. Maximum value is 0.33. So only 0.33 is kept. Again, this move to this. Maximum value is 0.55. It is 0.5. Again, it is moved to this. Here it is 0, 0. Maximum value is 0.33. Again, move to this. So we are keeping maximum value among the 4 pixels. So because these values are not very important, we will keep the maximum value because we have to reduce the complexity of our model. That is why we have to do all these functions. So by using the pooling layer, we can reduce dimensions to a great extent by removing the unimportant data. Fine. Now, So this is the basic about. After that, your output layer is there and softmax layer is there. Now, if you have heard the word parameter and hyperparameter, these are the two important terms in case of any neural network. Parameters means the values which are upgraded, which are learned during the model is training time. Fine. Means it will be parameters are learned by the model during the training time. Like I told you, these filters, these are the filters. These are called the weight values. In the first layer, some values are given randomly. In the second layer, again, these values will be changed. So these weights will be learned automatically by the during the training time. We are not fixing these values. It will be learned by the model itself. So these are called the parameters. Plus bias value is also learned by the system during the training time. So weights plus bias will be learned by the model during the training time. Like in this figure, if you can see, these weights and bias will be learned by the model during the training time. And what are hyperparameters? Hyperparameters means like this is a system. We have to decide how many convolution layers will be, hidden layers will be used. Like here we have used one layer. This is a one layer. But sometimes we will use two layer, three. Number of layers you will use, the higher the number of layers, accuracy will be better. But same time complexity will be improved. So we have to select between the how many hidden layers we have to use. So these are called hyperparameters. Initially you have to decide how many number of layers you have to use. So, but meaning of hyperparameter is that which are set up before the training model. Means if we want to train any model, initially we will decide some parameters. So those parameters which are decided before training the model, those parameters are called hyperparameters. So these are the hyperparameters: number of hidden layers, units in each hidden layer, how many nodes, how many neurons in each hidden layer. This is decided before the training model. Activation function, like I have chosen ReLU activation function, or you can use any other activation function like 10H, leaky ReLU, or number of research is going on the activation functions. How many iterations, how many, what is learning rate, number of filters, what is the filter size, what is the window size in pooling, what is the stride rate in pooling. These all parameters has to be decided by the trainer itself before the training the models, and these are called the hyperparameters. Fine. So I think deep learning is very easy. You decide, just change the hyperparameter value, and you can see the accuracy of your result. So it is very easy to change the hyperparameters, and you can check the output of your model. Now, I think I have discussed in very short time what is machine learning, what is deep learning. Now computer vision. I told you what the computer vision is doing. Computer vision is doing the same thing which the human do, but it is working on only on images. So computer vision in where we can analyze and recognize events happening around them, like whatever the human is doing, like analyze and recognize events happening around them. Like what is the kind of scene, what objects are there. We can easily see there is a car, there is some home, there is again some vehicles are there, how far the building is away from this car. So all these observations are done by the human being, and same thing has to be done by the computers. Then it is called the computer vision. Like if you see picture of this, you very familiar picture of Amitabh Bachchan, everyone comes in mind that yeah, this is a Amitabh Bachchan, and I don't think this one is recognized by everyone. How we will recognize Amitabh Bachchan? Because from our childhood we are our system, our brain is trained about this picture, that this is a Amitabh Bachchan, but we have never seen this picture, so we cannot say, oh, who is he. So the same way computer vision works. If you train the model again and again, showing this picture again and again to the model, it will easily recognize, yes, this is a Amitabh Bachchan. And second time, it can recognize. But if you see this picture 1 year after, you can forget. So number of times, number of images has to be given to the machine or computer to make the system, good accuracy to recognize the images. So seeing the as the brain works, similarly, machine will be work. By training lots of data, by training the model with lots of data, your accuracy will be higher. So we have to make our system working in the same direction as the human is doing. Now, if we talk about how the our computer is intelligent, if you talk about chess, even computer has beaten the world champion of chess. So how intelligently computer can work? you can understand that computer can, by training the computer with different good algorithms, computer can move better than a world champion. This is a very basic how your computer will work on images. Like this is the image, how your eye can see any image. But in computer, images are converted into the matrix form. Like digital camera, if you are taking, in the first stage only, it will be converted into number of bits. Fine. So computer are not working on images, it is working on some data only. No, in this slide we are showing in some application computer is working better and in some application human is working better. Like if you want to add thousand of 8-digit number or thousand of 100-digit number, something like this, computer will do it in fraction of second, while human will take long time. Similarly, if you want to draw complex images, 3D, 4D, 5D, it is very difficult for human being, but computer can do it very fast. If you want to store and retrieve large amount of data, it is very easy with the computer, while it is will be difficult for you. So when some laborious task has to be done, it is very fast by the computer, can do laborious task very fast. ठीक है. And computers don't have the human factor of tiredness. Like if you are doing long processing of your data or adding, addition, multiplication, you will tired after some time. Oh, now my brain is not working. But computer don't have the factor of tiredness. This is very important. And in which application your human will do better? Like if you want to recognize either it is a cat or dog, in fraction of second you will say, yeah, it is a cat or it is a dog. But if the computer has to do it, if the computer want to recognize either it is a cat or dog, you have to feed lots of data, you have to train the model, and they again the accuracy will be not as good as the human accuracy is there. So in some applications human is performing better, and in some applications computer is working better. So in short, what we can see, what the computer vision are doing, computer vision includes acquiring, processing, analyzing, and understanding of images. Fine. Means first it will capture the images, then it will process, analyze, and then finally it will take about decision about the images. So CV imparts human intelligence into machines. Same thing what AI is doing, but it is working on the images. It imparts human intelligence into machines. Now, what will be the input data for the computer vision? Data may be from multiple cameras, medical images, satellite images, or video sequence, something. Fine. Now, due to advancement in deep learning, especially using convolution neural network, computer vision is doing amazing things because of your deep learning. Deep learning is very in nowadays. Fine. CV computer vision deals with image classification, object detection, image segmentation, image recognition, image or video processing. So mainly it is working on computer vision is working on images. Now what is the relation between image processing and computer vision? Now image processing is the image processing, it is subfield of your computer vision. Computer vision at last doing some decision, some intelligence is involved in computer vision. But what the image processing is doing, it is just some mathematical operations are used on image processing, not any intelligence is used. Like if you want to add two images, if you want to take inverse of the image, or if you want to enhance your image for some purpose. So by using mathematical operation, you can enhance your image, or you want to remove some noise from the image, you can easily do by using the image processing technique. So image processing is the subfield of computer vision, while computer vision do the some advanced tasks, where advanced tasks like some decision needs to be taken. Then computer vision is used, but it is using some initially using some image processing techniques. So in computer vision, you can say artificial intelligence is there, machine learning is there, image processing is there. This is the sensor technology. Sensor technology means you have to first acquire the image by using some sensor. Then you will work on the images only. Sensor technology is there, computer graphic is there. Fine. So all these are the interrelated fields. Again, this is shown by this diagram, same thing. In image, computer vision, low level processing, intermediate level processing, and the high level processing. In low level processing, first we will acquire the image. I told you some sensor is required to acquire the image, because in computer you have to feed lots of images. After that, pre-processing. Here the image processing techniques may be used. Pre-processing is you want to remove the noise, you want to enhance the image, something like this. You want to make image in the better way, or you want to normalize the image so that this can be further give the good results. So some mathematical operations can be applied on this image, because some various types of noises are there when you capture with the camera, something like this. You can remove the noise, you can normalize the image. This is called the pre-processing. After that, intermediate level processing, you are using segmentation and representation and description. And at the later stage, you are using recognition and interpretation, which is here the AI will come into the picture. Finally, you want to label that yes, this is the image of this person, or this dog, or something like this, whatever it is, or this some river, satellite image, whatever decision you want to take. So these are the various first is the image acquisition. So you can use various type of cameras, embedded camera, laser range finder, some DSLR, webcam. Many type of sensors may be there to acquire the image. This is how the image can be segmented. This is the image segmentation. After that, like at the higher level, you have to recognize, like in this image, this is a person, this is a car, this is a helmet, this is a motorcycle. So all these are the object recognition methods. So some AI decision making stage, this is the last stage of decision making, which involves some intelligence. Otherwise, initial methods are just mathematical operation and you can get the output. Now, object detection. Like in computer vision, I told you that main thing which is the part of the computer vision is object detection and classification, or you can say segmentation. Fine. So what we will do, if you want to find either the which objects are present in the image, then this is done by the computer vision. And various machine learning or DL, deep learning techniques are used to produce the meaningful results. So why we are studying here machine learning and deep learning? Because in computer vision, to get the result, we have to use either machine learning or deep learning techniques. But in most of the time, we are using deep learning. Now, object detection. In object detection, there may be two, three things like image classification, detection, and image segmentation. What is the meaning of that? Like, if you want to classify the image, either this is a dog or not. So it is very easy. This is called image classification. Neural network output will be a very simple, like one if it is a dog, if not a dog is not present, it is zero. So this is a very simple problem. Either the dog is there or not. Second, you want to check either some image of dog is there. If yes, it is there, then find the position of the dog. That is called object detection. Yes, dog is there or cat is there. You have to create some bounding box in the image. Yes, this is a dog and here it is a cat. This is called object detection. Classification means either the object is present or not. In second thing, we have to find the location. In location, you are creating the bounding box. And what is image segmentation? Here we are just creating the bounding box. Fine. But here we will exactly tell the shape of the objects, like which pixel, like image is formed of some pixels. Which pixel belong to, like this pixel does not belong to any object. This pixel belong to cat, this pixel belong to dog. So image segmentation will find which pixel belong to a which particular object. So exact shape of the object will be comes in the case of image segmentation, because each pixel will be identified either it is a cat or it is a dog. So there are three types of things. Classification, either dog is there or not. Object detection, yes, dog is there and this is the location of the dog by some bounding box. Here we are telling exact, shape of the dog and cat by finding which pixel belong to which particular object. Again, in object detection using computer vision, machine learning basic techniques, if you want to study, these are the main technologies which are used in machine learning. Scale invariant feature transform, aggregate channel features, Euler-Jones phase detector, histogram of oriented gradient features. So these are the different methods where we have to study the features and then use classifiers. So these are the machine learning algorithms for the machine object detection, and these are the deep learning based techniques. In the deep learning based techniques, everyone, even this structure is also using CNN. All the techniques are using CNN, convolution neural network. And the main technique which are using nowadays is the YOLO technique. You only look once. Fine. This is again also using CNN. So we can say in short that how the object detection methods you can work on. There are these different machine learning techniques and the deep learning techniques. So we will study in brief how the you only look once will work using CNN. You only looks once is a very object detection algorithm and it is very fast, and now almost a standard way of detecting objects, YOLO. And time to time various versions are coming, V2, V3, V4, V5. So what is the difference between version V3 and V2? Like accuracy will be improved in the latest version. Fine. So YOLO is a very standard way of detecting objects nowadays. Again, how the YOLO will work? Like initially I studied about CNN. Same thing. This is the beauty of deep learning, that every time you are using the same model. But what you will do? Number of hidden layers. Like here it is a one hidden layer, second hidden layer, two hidden layers are there. So you can use four hidden layers, five hidden layers, and you can find out the results. So seeing after that it is, I told you, this is a fully connected layer. We will flatten the matrix. After that this is the output layer, softmax. Like there are number of, suppose 10 objects are there, so probability of all the objects we will found, and which has the highest probability, we will say yeah, this is the this object. So same type of model, if you studied it once times in CNN, same type of model will be used in your all the structures. Only the thing, you have to change the number of hyperparameters and you will see the accuracy of your result. Like if you want to see the image classification problem, you want to classify either it is dog is there or not. So it is a very simple two-stage classifier problem. Second time, if you want to find the location of the object, so you have to create some bounding boxes and find the x-axis and y-axis of this box. So number of value, this vector value will be increased in case of your neural network. Like in case of object like localization, what will be the value of your output? Suppose this is a 7 values vector, output vector in case of neural network. PC will tell either the object is present or not. If the output this object is present, then its value is 1. Fine. Now, bounding box. What is the value of this from x-axis? This is 50 and this is 70. Bounding box x-axis, y-axis. Width and height of the bounding box. What is the width of bounding box? What is the height of bounding box? These are the two parameters. C1 and C2 for PC was telling either the object is there or not. But this C1 will tell if dog is present and 1. If person is present, then C2 will be 1. Fine. So these are the 7 values which will tell you which what is the object and what is the position of the object in the output of the neural network. So this way we will train the neural network like this. Here, like for the dog, we will train the system and we will get this value. Dog के लिए 1 है. For this person के लिए 1 है. If there is no object, this value is 0. So all the values are 0 because there is no bounding box, x-axis, y-axis, height, width, all the values are 0, 0. So by giving these values, we will feed the system to the CNN and we will train the convolution neural network. And at the later stage, when we will feed some unknown value, this dog value, system is already trained, it will give you this vector. And from this vector, we can see, yes, this dog is present because this value is 1. After that, this is a x-axis and y-axis of your dog. So you can see where the location of the object. And this is the width and height of the object. So this is how you can see the object location of the object using CNN in computer vision. So I'm telling you, I'm just giving you the brief idea, so anyone can work on this and they can study in detail. Similarly, if there are two objects in the same image, it means how we will find out? We will take the centroid of the image. Like for this dog, if the centroid is there, then we will say that in this grid the dog is there, in this grid person is there. So this is we will divide the whole image into some parts. Like here we have connected into 4 by 4. So by this we can see in which block dog is there and in which block person is there. So this is how we will train the image with the two objects. So just skipping this because of short of time. So this is how there are some problems, like if in one box both the centers are lying, person and dog, then how we will do? So then in case your length of the vector will be increased. So this is how you can work with the object detection using CNN in case of your computer vision. So when you work on such kind of images, you will find various kind of problems. So depending upon the, like if these two objects are very close, so it will be difficult to identify. So depending upon the image, information, accuracy will be different. So when anyone will work on any such kind of problems, then we will face different problems and we will rectify it. So now I think we have studied the AI, ML, then computer vision. And basically we have discussed in very short time what is deep learning, and in various applications similar kind of model can be applied to your any kind of problem. So you have to make your model robust. You can use any inbuilt models are available on the GitHub, and you can use them, and you can train on your data, and you can check the accuracy of your problem. Fine. So I think deep learning is very powerful tool nowadays. Everyone can use that in the field of artificial intelligence or computer vision. Now, what are the various applications of computer vision? Obviously, in all the applications, we are using AI. I will take one by one, like in very brief, in 5-10 minutes. Like, do you say OCR? Everyone has seen optical character recognition. Even in colleges, OMR sheets are scanned, and then automatically those scanned images are converted into test data. Means automatically we are feeding numbers into the computer. So this is done by OCR. Behind that, some computer vision technology is used behind the OCR, and it is also used in banks for getting information of check and credit card. Similarly, face detection for either for entertainment, everyone using in Facebook or in your mobiles, you are detecting the face of a person. Fine. For the security purpose, like if you want to enter somewhere, so for that Aadhaar card purpose, you can use your face detection technology, that is a part of your computer vision. Fingerprint, FBI of America is using fingerprint for the crime and forensic application. So fingerprint is a very important biometric application for your authentication. So all these are the results of your computer vision only. Like nowadays in computer, either in computer or in your mobiles, you can log in without a password by just giving your fingerprint or your face. So if you see just around yourself, everyone, every time, everywhere, everyone is using you computer vision applications. Fine. Smart shutter is there in the smart shutter book, smile shutter mode. What happen whenever someone will smile, it will click your photograph. So what is happening behind this? It is behind this we are having computer vision technology using AI. Like this woman has changed her identity, but what happened due to the some iris recognition technology was used, and she could not change her iris. So due to that this criminal girl was caught. So iris recognition is very important for recognition. Like in the entertainment purpose, special effects, shape capture, motion capture, everything is done because of your computer vision. Interactive games nowadays, students, all the persons are doing using interactive games. All the space, whatever research is going on in space, like we are capturing the images through satellites, and then we are working on that, analyzing them, and then taking some decision. This is all the part of AI with computer vision. Satellite images, what is a part of your agriculture, what is a river area, what is a forest area. So everything is done, analyzed, and decision is taken by the computer vision, because we are capturing the images, analyzing, and then taking the decision. Industrial robots, various robots are used in industry to for the inspection of various products, and this is a 3D X-ray which is used to find any defects on things happening around you, or like if some PCB is there, some PCB track is broken, or some component is missing in the PCB. Every kind of fault can be tracked by there are such kind of robots. So this is also the part of your AI with computer vision. These are different kind of robots. In kitchen you can use for dishwasher robots. Everything in very soon will be around us in very few years, and this is all because of your artificial intelligence. you know Nowadays cancer is detected at the very early stage. How it is detecting? Because of your machine is capturing the image at different slicing of the brain, and they are detecting even micro tumor at the very early stage. So how this is done? This is due to only the computer vision. So you can see all these applications now in shopping mall. You can check how many number of passengers are there, how many visitors are there. So store performance can be checked just by taking all this data and analyzing that data. Some person has made some recent paper is there on the social distancing detectors, in capturing the images in COVID, and then how who has not maintained the social distance. So all these things are done by the computer vision. Driverless car is, everyone know driverless car, and it will be very soon around us in very few years. And this will be, very big blessing from our artificial intelligence. Like everything is done by your intelligent system by just capturing the images from this camera, and then using the computer vision with AI, we can detect road signs, traffic lights, speed limits, recognize obstacles such as cyclists or pedestrian. Everything is done because of your AI. So these are the various application in waste management, either how many part is waste and how much part is can be reused. So this all type of processing is done by computer vision. In agriculture also, either the flowering detection, plant disease detection, crop monitoring, all everything is done. Means we are capturing the images and analyzing and taking the decision. So these are part of computer vision. Similarly, real-time surveillance. What it is doing, it is capturing the images and checking what is doing unusual around us. So for security purpose, real-time surveillance. This is a ball tracking system in sports. Like either referee can easily take the decision, either the sports person is out or not. So exact decision is taken by capturing these images. Fine. Now these are the various basic, like we can say Ola, grocery, Grofers, Big Basket, Flipkart, Snapdeal, Myntra. All these are using computer vision techniques behind it for taking the decision. So this is all from my side. These are the big startups in computer vision, and these are all are at the very early age. So anyone can thought of some application of computer vision, and we can do anything. We can improve something around us by using computer vision with AI techniques. Yeah. With this, because I have some meeting at 3:15, so I have to wind up in time. So if there is any question, please do ask. Just
Thank you, ma'am. Thank you for your session, ma'am.
yeah.
Participants, do you have any questions you can ask? Some of the questions posted in the chat box, ma'am. Think, one of the
What
participants.
are the challenges? Yeah, what are the challenges? What I have can see the question. Actually, I told you in deep learning what is the challenges. Main challenge is that you need some GPU because you need lots of data to train the system. So large amount of data, because deep learning will give a good result when you are training the system with large amount of data. So big challenge is to have a large amount of data to train the system, and training type is very high in case of you have to take patience, like sometimes months or weeks are required to train the system in case of deep learning. So I think you must be satisfied. This is a challenge in deep learning technique. Training time is large and you need large amount of data. Yeah, any other question? What are the recent research areas in computer vision? Research areas recent are, like I told you, like most of the startups are working on driverless car. If you are improving any feature like obstacle detection, object detection, you can take any one thing to improve something like object detection. If you are improving the accuracy, if you are going doing segmentation part, classification part, object recognition part, so all the applications which I have discussed in very few seconds in the last few slides, you can work on any topic. That will be your research area, like object detection, face recognition, biometric recognition, robotics. In robotics also you are using computer vision. So all these are the topics for your research in case of computer vision. Yeah. Any other question? Okay. Thank you. So
Participants, any other questions if you have, you can ask. Thank you, ma'am. Thank you for your valuable session, ma'am. The session was very informative to us. Thank you, ma'am.
thank you so much for inviting me. Thank you once again. Okay. Wish you good luck. Bye bye.
Thank you. Thank you, ma'am. Thank you for spending your valuable time with us. With this session, our participants have an